So welcome to our presentation about the asset administration shell as the core standard for a digital twin. Our title is Mission Digital Twin Asset Administration Shell Realized by Open Source. My name is Christian. I'm the second name here on the slide. I will do this presentation together with Thiago from SAP. And my role today is as a General Manager of the Industrial Digital Twin Association. I will give you an overview about what we are doing in the association and what's about the asset administration shell. And Thiago will show after that what we are doing on open source level. So you see here the agenda. I will give you an introduction and the motivation. What's the digital twin? What's the association behind this? And what's the asset administration shell? Yeah, Thiago, you will go on with the Eclipse Digital Twin Top-Level project, which we have established. And behind these top-level projects, we have specific 4 open source activities running there. And Thiago will give you an overview, a little bit a deep dive, what we are doing there. And we will close with a wrap-up. So, what's the IDTA? The Industrial Digital Twin Association. We are the association for the topic of digital twins for industrial goods, and we are a result of the movement of Industry 4.0. So it's the next evolutionary step we are going. So we started with the topic of digital twins in 2013 with the topic of Industry 4.0. In 2015, the first concept of an asset administration shell, of a core standard for digital twins, raised up. It was more on the level of papers and PowerPoints. First proof of concepts and demonstrators have been shown on the fair, in SPS fair in 2019. There was to see the first industrial implementation of the asset administration shell. And together with this, that we saw, okay, there's the first implementation of this technology. The IDTA was established in 2020. And what's our vision? Why the IDTA? Next player on the floor now, a new association for the topic of digital twins. Our vision is that we want to establish the asset administration shell as a core standard, as the worldwide open standard for industrial digital twins. Established in 2020, September of 2020, we started with 23 founding members. Together we count 82 members. So when you look at this logo wall, you see many companies from different areas, different branches. We see on the one hand smaller software companies. We see also larger software companies like SAP, but we see also the component supplier like Rexroth, for example, or Lenze, who do the drives, for example. We see also machine builders like Trumpf. You see like robot builders like the KUKA, for example. But you see also the big corporations like Siemens, ABB, Schneider Electric, as well as end users, for example, like Volkswagen. So there's a high diversity of different companies in the IDTA, since the technology is in front of the idea why these companies are member in the IDTA. And this is what it drives, the drive behind and the motivation why the companies are doing the work and the standardization work in the IDTA. So you see, it was also a bet if this idea of a new association could be a good idea. And when we look at the curve now, we see it was a good idea because response from the market is quite good. We are growing in the membership. The count, you see we started with 23 members. Today we count 82 members in the IDTA. And when you have a look, what's the community about, that we started as a German-European association. Now we are growing in a world with a worldwide commitment. You see that we have now 30% of the members outside of the German-speaking area. So we have different companies from different countries representing. And you see that we have to now the same challenge like every big company has, that we have to respect the time zones with a range of 16 hours. So our meeting language also in the IDTA now is completely in English, since we are now very international in our working groups. I said, okay, the vision of the IDTA is a worldwide standard for the industrial digital twin. We want to establish this one, and we have different steps we have to go there, and this is our mission. First mission point is that we want to build up a global community in the IDTA, so like you see in the membership, this is a mission we are doing quite successful today. Second mission is that we want that we are based on open source technology. This is why we are today presenting here at the Eclipse conference. The asset administration shell is a meta model, it's a first information model, and this has to be serialized in different technologies, and this will be implemented by open source technology. And this is what also Thiago will show in the second step of the presentation today. The digital twin is a concept, an overall concept, but the informations which should be feeded into the digital twin is a result of different submodels from different use cases. And what we want to do is that to deliver an open access for the different information models for the digital twin, so the data can be live feeded into the digital twin and the asset administration shell. And use cases is one of our key pillars. Everything what we are doing in the IDTA is always use case driven. And we are looking for matching use cases, what kind of benefit can be created by the asset administration shell. And when we create this know-how, we also want to spread this know-how, and we are building up today a training course for different implementers and also decision makers. Inside the IDTA, we have some working groups. You see a typical structure of an organization like this association. So we have the members, we have a board, we have also the office. So I'm out from the office of the IDTA, and we are organizing 6 working groups. One working group is the Open Technology Working Group. This is the working group which is really relevant for the community today here at the Eclipse conference. The focus of this working group is the open source technology for the asset administration shell and also the security topic. But we have also working groups like the submodels of a digital twin and the harmonization of the different submodels we are running, the quality management of the implementation of a digital twin and also the implementation of submodels and the certification. We have a working group for establishing the training curriculum. We have a working group for the use cases where we show different asset administration shell applications, and there we want to connect also the implementers with each other. And we have the working group marketing. It's about the branding of the asset administration shell and branding of the association. So I took many times now the wording of asset administration shell. I said some things to it, but what's the asset administration shell and what's the difference with a digital twin? And the focus. In the IDTA, we are really focusing on industrial goods. So these are the factory suppliers, for example. And as an example, you see here on the slide a robot. And when you have a robot, you also go through its life cycle, like every product, also consumer products. So we have the planning, the development, the construction, the virtual commissioning, as well as the operational phase, the maintenance, and yet end of life, also the recycling. And when we look through the different phases every good industrial good has to walk through, we see that digital twin is nothing new. Digital twin is something which already exists as a technology, but mostly application-driven, mostly very specific, efficient, and only focusing on specific life cycle elements. So we have digital twins, for example, for the planning and development. These are tools, for example, for the product life cycle management, the CAD tools, for example. For the construction, we have digital twins. For the virtual commissioning, we have digital twins with its standards, like automation ML, for example. In the operational phase, we have digital twins, for example, for the controllers and the live data, for example. So for every phase, digital twins already exist today. But what's new with the asset administration shell? The idea is to get these different digital twins interoperable with each other. So we need one meta standard overall over these different digital twins for each life phase. And that's the so-called asset administration shell. And maybe now you understand why this wording also. When we talk about the asset, we mean the industrial goods. So the asset would be here, for example, the robot. And what should be administrated? These are the different informations from the different life cycle phases. We have informations from the planning, like the CAD data, for example, or the live data from the operational phase. These are data which should be administrated. And the central hub is the shell. So this is why the asset administration shell got its name. And the idea here is that by standardization, the companies will be enforced to get into an efficient scaling, and that they can represent their industrial goods for the entire life cycle for their goods. The asset administration shell itself is a model, it's a meta model which has to be implemented. So this is why we are working on an open source platform today, and we are also as IDTA member of the Eclipse Foundation. And the asset administration shell really is the basis for the interoperable digital twins. And we have two main or two core standards we are based on. We have the part one, it's the structure of the asset administration shell, and the part two is the interface of the asset administration shell, so an API, so you can get a pub-sub, for example, architecture of the asset administration shell, and this coding will be done by open source technology, and it results into an open source software. So we are now member as an Eclipse Foundation, in the Eclipse Foundation, and what we want to achieve is to build up the global community to have a movement to implement more this technology in the future. For this, also as in a strong partnership with the Eclipse Foundation, we established in the Eclipse Foundation a so-called top-level project. It's the so-called Eclipse Digital Twin. So when you have a look on the website, you will find the Eclipse Digital Twin Top-Level project, and inside of this project you see 4 specific related projects. It's the Eclipse Asset Administration Shell Exchange Package Explorer. It's the implementation of the Asset Administration Shell for Java. It's the web client, and it's also the project BaSyx. Thiago will show you a little bit more about it, what we are doing there. So when I say interoperable digital twins, why to do so? The first argument I showed in the slide before is that we want to achieve a representation of the complete life cycle of the industrial goods. So this is one goal why this motivation from the different companies is so high. But the second one is to integrate the whole supplier and customer value chain network. When you have, for example, here, the different life cycle phases of different goods, you see, for example, the supplier paths. This could be, for example, a sensor, a drive, or something like this. Also, this drive has to be planned, has to be constructed, commissioned, and after that is in its own production. And this will be integrated, for example, into a machine, like a machine tool, for example. And there's a supplier and the customer relation here. They have to interact with each other, and they need the data from life cycle to life cycle. So it's very important to get also an interoperability not only between the different life cycle, but also between customers and suppliers. And when you look further, of course, the machine is part of the factory and part of a plant. So also there, the information is very important to get into, for example, the factory when it comes down, for example, for the virtual commissioning, the digital factory, for example. These are all data which could be delivered by the suppliers of the factory. And very important, by administration of the data, not only the whole integration. What's about? We do not want to make a double work. We do not want to create a new standard for things which already standards exists. We use standards, we use the tools which already are there, but we really want to just administrate. And when we have a look on what kind of data has to be administrated, we also see that there's a different form of representation of the data. For example, in the engineering phase, you see out of the product development, there are 3D geometry models. There are drawings, there are simulation data, like Simulink, for example. There are properties which are stored in databases, for example, like in eClass. And on the other hand, when a drive or a robot will be delivered to the customer, they also have to deliver the documentation for the tools and for the robot, for example. So we need documentations like the installation operational instructions, the certifications, and so on. These are important data for the customer to integrate, to onboard the machines on the shop floor, but mostly represented just in form of a, for example, PDF document. But very important for the customer for the onboarding. And on the other hand, when the robot, for example, will be installed on the shop floor and the controller, the PLC, will be connected to the network of a shop floor, that we have order data and live operational data, live data out of the PLCs, which should be administrated in a digital twin. So this is also there, a connector there to the asset administration shell, how it could be integrated. And for this, we develop in the IDTA several submodels. This is the second working group you have seen on the beginning slides. So we have submodels, for example, for the digital nameplate, contact information, or for example, the handover documentation. This is, for example, where the certifications, the manuals, the instructions, for example, will be structured on meta level and always linked, to, for example, by the supplier in the original documents. When you look into the live data, we are now creating a submodel for OPCUA, for example, as a connector between the OPCUA server on the PLC, for example, to the asset administration shell on the IT level. So this is about now the submodels, why we are creating and developing this one. Just as a connector for the different existing standards we have already on the market. And the use cases behind this, because I said in the IDTA we are really use case driven and all our discussions are use case driven. Benefit is the first goal we have in mind. I have here a list of top 10 use cases we are looking at. For example, we have for the global impact use cases like the product carbon footprint for the industrial goods, as well as, for example, the energy monitoring for components, for machines, but also for the factories, for example. And the basis of all this is the digital nameplate. We need a nameplate for every industrial goods to make also an identification, a description, and so on. On the next level, we have also the smart manufacturing use cases. These are already implementations we have realized by the member companies. For example, by the company Stahl, we have an implementation of the digital nameplate. From the company Wittgenstein, we have an implementation of a service portal based on the asset administration shell. From the company Lenze, we have an asset management system based on the asset administration shell. And by Volkswagen, we will see in the future an asset administration shell-based pilot plant to show how IT tools like the asset administration shell can create a new value by interoperability in the factory. And when it comes down to the components and to the assets, we have use cases like the onboarding of the different assets on the shop floor, or when we have a look on the sensors, that we have an open standard for Industry 4.0 sensors, as well as open standards, for example, for the different drives. These are use cases we are talking about in the IDTA. So this is just my overall overview what we are doing in the IDTA, and I would like to hand over now to Thiago, who will tell you about the detailed or specific projects we have.
Is it working? Yeah, great. Yeah, thank you, Christian, for the very interesting overview on IDTA and what is the digital twin based on the SMC shell. What I'd like to give you now is just an overview on what's going on the open source topic. Of course, due of the time, I will be pretty limited on being rather high level and just explaining you what are the projects that are going on. And hopefully next year we'll be having more sessions on this topic that we can go even deeper, even showing the code and so on. Most of the content of the slides has been already introduced by Christian. I just want to stress out here that I'm talking on behalf of the Digital Twin Top-Level project, which is led by Andreas Olszewski, and I have also the pledge to be a member of this Digital Twin Top-Level together with Birgit and Mika Plage from the Eclipse Foundation. Yeah, so let's just go a step back. What was happening before we created this partnership with the Eclipse Foundation, right? I mean, actually, at the very beginning, when the association share concept was established, there was also the idea, how can we bring these concepts in a more tangible manner for the industry? And of course, the easiest way to do is to do code, right? To implement the specification as code. And we have been, like the ASX Package Explorer or the Eclipse BaSyx are very good examples that at the very beginning were used to provide, accessibility to this technology for the industry, but rather, on a demonstration level. But as Christian just mentioned, we want to, bring this in a rather global level, and we need more, of course, guidance as to how we do this in open source. And that's why we are now working together with the Eclipse Foundation. I'm very happy to be part of this family. What I want to show here, I mean, of course, it looks like as we would have a lot of projects. We're not that far, but rather we have already a concept how we want to drive this as open source. And we don't want to have individual projects that do not correlate to each other, but we envision that an open source for digital twins need to have the components that you can see here, like UI, the implementation of the specifications, like repositories, registries, right? Security, and of course, some libraries implementing the meta models. Yeah? And of course, we need add-ons to provide everything on top of the specification of the SM shell. So what we're doing now, our first step, of course, was to bring some projects to the Eclipse Foundation, which are seen here. For example, the Package Explorer, the AS Web Client. BaSyx was already there, but now it's part of the top-level digital twin. And the AS Model for Java, which also contains the transformation libraries. And today, I'll be talking about these 4 projects in a rather high level so that you can have an idea what is going on the SM session shell. So let's begin with the AS4J, or the Eclipse AAS model for Java. So it began pretty much on a cooperation between Fraunhofer and SAP with the idea, we need enterprise-ready, reusable libraries to implement the meta mod of the SM session shell. And this activities has been evolving so that we're now working together with Eclipse Foundation and created this project, right? And there is already some reusage of these components, like even within the Digital Twin Top-Level project, like BaSyx has been planned to use, and also other projects like Fraunhofer SM session shell tool, which is also using these libraries as a basis for their implementations. This is using the Apache public license, and you can get here some access to the code by this link. So let me give you a deeper, almost deeper overview on what is the AS4J. So the AS4J comprises pretty much of our 4 components, which really concentrate on the implementation of the SM shell, like model, which implements the data structures. We have a component called data formats, which enables the serialization as well the deserialization of several formats as specified by the SM shell. We have a validator, which is, of course, very important because you want to ensure that whatever you've been using, it must be compliant to the specifications. And of course, we have a generator that supports whatever we are doing here as a code is aligned with the specifications that are being published via the IDTA. And on top of this, we have what we call transformation libraries, which add additional functionalities that are actually not covered by the specification, like the mapping to automation MR, which is needed for engineering, as well OPC-UA, which is needed for manufacturing and also operation within the shop floors. Yeah, so let's talk about the current state and what we are planning. So currently, we are actually we achieved now that the code are now completely at the Eclipse Foundation. So as you see here, we also use this as a chance to restructure the repositories in a manner that's more easier to consume. And the next step, and actually this is what we are concentrating pretty much, is on updating the code to the newer specifications that are being in work. So yeah, and of course, please reach to me out if you have questions. And of course, we're very happy to welcome users as well, adopters as well as contributors. So let's talk about now 2 projects that are more, I would say, providing functionalities to user interfaces. So this is a project driven by our colleague Tobias Klausmann from Linse called Eclipse AAS Web Client. And the idea is, we want to provide here a client that you can use in every computer as with your web browser, enabling you to access the SMSH shell as instance, right? But also provide you access to registries, which is pretty much the idea of like a phone book where you can look, okay, where is actually a specific SMSH shell. So you look for this ID and you get an endpoint back. And using the endpoint, of course, you can access the entity of the SMSH shell or the entity of digital twin that you're looking for. This is written as a JavaScript and also available with the Apache public license. And you can access here the GitHub repository if you want to have a look at code. Unfortunately, I think the solution is not so nice here, so you can't see here very much. But the idea would be to see, with your web browser, the content of a SMSH shell. And I'll just go through slides further. So we have not much time anymore, just to give an overview how it looked like if you would have, using the functionality for registries. And by the way, this is also what I want to stress out. This is not unique open source project, but we try that there is a connection between the project that we are bringing to the Eclipse Foundation. So for this specific case, you can use the web client to access the registries, which are then deployed via Eclipse BaSyx. So now let's talk about another project, which is, I would say, one of the very first projects that you get access when you talk about the SMSH shell. Maybe it's the first open source project, I would say. And actually, I was very happy that on the IoT community day on Monday, that our colleague Christian Glom was also mentioned this project, also mentioned the SMSH shell. So it was actually today, not the first time, but already on Monday, we were talking about the SMSH shell. And he pretty much showed this interface here. And actually, this is the holy grail for the SMSH shell. So you can generate SMSH shells, edit, open, also submodels, and edit them, connect to repositories, right? But luckily, this projects led by Andreas, and he was also nice to provide us a demo. And I won't talk much. I will let him also just show how it works. So here is a video.
Yeah. Hello, my name is Andreas Orzelski. I want to show you the ASX Package Explorer. I have opened an ASX file, and we see an AAS from a VDMA Fluid demo. By the Package Explorer, we can view it. So, for example, let's look into the nameplate submodel here, or other submodel like handover documentation or technical data, which are provided in this AAS. By the Package Explorer, you can, of course, also edit it. So let me change to edit mode. And you see here on the right, with edit mode, you get a lot of controls. There are also a lot of hints, like here on the bottom, for mandatory information, or if the syntax is not correct. And so very easily you can make changes or insert further elements into the AAS. The AAS Package Explorer also includes various assistants. Here these gray lines, where the information is easier structured for the user to enter it, besides entering it in the model directly. So, for example, especially in the handover documentation, you get a nice view of the documents and then can also view and open the document in here. Now let us connect to a server. This is a server here on admin.shell.io.com with various AASs, and this server here includes security. The link to the REST API is this one, and in the Package Explorer now let's connect to the repository. So we are connecting, and the Package Explorer loads the directory. This repository is configured that the first AAS I double click on can be loaded without authentication, but for any other AAS the user is requested to authenticate. We are connected to an OpenID server there. To have it better readable, you see the self-configuration page here, and on that OpenID server are root certificates which are used to check the user certificates and are also used to filter user certificates. And I simply go on here, and we do not look on the debug messages coming. But here on my computer I have two valid cases, one from Phoenix Contact, one from Industry 4.0 platform. Let me just choose one, and we go on, get an access token, and are authenticated. Just to mention it, on that server here on the bottom, we have the security settings for the server and the related meta model with the policies. Finally, I have also connected to another server which includes real-time data, which includes time series data. I download this here, and here we see the time series data. The Package Explorer includes a nice viewer for such data. So let me just double click. On the top we see in the viewer to the right the actual values, and here on the bottom we also see historical values which are stored as time series, and we may also open this in a separate window to zoom into. So such functions are also part of the Package Explorer, and also in this data you find examples of signing, so that it's really clear that this is a trusted source. So here in the AAS you see the signature, and also again here the certificate chain by the creator of the data. So thank you very much for listening.
So what you saw that is how easy it is to interact and create digital twins and change, right? And the values, of course, you have digital twin that you can use holistically throughout the life cycle and be always able to access the data that is being generated for a specific asset and correlate to the specific digital twins to it. And finally, just before we close up the session, I just want to give an overview on BaSyx. I won't spend much time because I think Eclipse Foundation already knows about this great project. But just for you, if you don't know, Eclipse BaSyx is pretty much one of the first middlewares for Industry 4.0, and it easily provides the components where you can deploy Industry 4.0 applications depending on your use case. And one of the strengths of BaSyx is pretty much that you have this off-the-shelf components that you can easily adapt to your use case, so you can deploy all of them or just some of them, whatever you need, right? It is also a pretty flexible project because you can use it as Java, C#, C++, Python. Currently, they're also working on Rust, which is pretty interesting, right? And yeah, so another thing, when I say off-the-shelf components, it's about implementations of the specification like registries, repositories, but also interfaces to database like MongoDB. And of course, if you just want to play around like the Package Explorer, you can also use BaSyx as a great introduction to the SMC shell as a digital twins, as it provides very easy examples on how you can use the digital twin. So, and with that, I would like to close the session. First of all, thank you very much for your attention. Thank you very much for EclipseCon for enabling us to be here. And of course, if you have questions regarding the IDTA, SMC shell, please reach out to Christian and to the open source projects. Of course, I'll be happy to be talking to you. Yeah, I'm not sure, we don't have much time. I think it's already lunchtime. We can go to lunch, and if you have questions, happy to talk there. Otherwise, I'll be here and tomorrow. And yeah, thank you very much.